Hey, hi, I'm live, and my name's Rob. I'm that developer dad, and happy 4th of July. Today, well, I'm originally from Canada. I've been living down here for a long, long time now, but my wife is about to go tubing with some friends of ours, and I figured most of the people that I really want to be talking to have the day off today, maybe. And it's early enough in the day that perhaps you haven't started your day's plans yet. But, if you have, that's cool. Today we're going to keep going with our townsfolk generator. And for new folks that are just joining us, that is going to be a dotNet application that helps me, a lazy dungeon master for a homebrewed D&D game, to quickly come up with non-player characters on the fly when my players ask me, hey, tell me more about these people, and so on. So far, we have created our static design. We've defined what the components are going to be and what their general purposes are. And then we created the dotNet solution, added the projects, and got those projects all referenced to each other according to our dependency discussion. And I should have switched over to the screen share before I started talking about that. So our townsfolk generator is it's just going to be a simple .NET application. The first client is going to be nothing more than a simple console application and some automated test projects. The console app, or maybe eventually some sort of front-end application, is going to call into our townsfolk manager, which is going to call methods on the DiceBag and the rule set to generate random numbers to pick from lists that we create to help me generate details about random townsfolk that my players run into. We've already set up the solution and added the product or projects that will host the code that makes these things happen. And that's all over in VS Code. Yesterday, we focused on the DiceBag because it's basically pure logic. It hasn't got any dependency on anything else outside of the things that .NET gives us. And that felt like the best entry point into our project. So here comes the Finder. I'll pop this over here. And I set up some automations on my Mac a while ago that let me open Visual Studio Code right from a project or a solution folder. Excuse me. And here we go. Oh, it updated overnight. Very nice. It looks like we've got some new features over in our source control graph. Right now, we don't have any incoming or outgoing features because I pushed to the remote branch last night after I finished up. And a bunch of stuff for Python and all that other stuff. Great. That's all good news. So yesterday, we started fleshing out the Dice Engine component. And we started with adding a contract. We don't need that console down here. And that contract is iDiceBag. And what iDiceBag is it's an interface that describes the behavior of any code component that's going to supply DiceBag functionality. We have the eventual ultimate entry point for this. And I haven't fully decided if we want to do a big long thing like that. We might want to do something a little bit more slick, but we'll get there. For now, we just want to get the random number generation, working. And That means we have to pass in the number of dice, what kind of dice we're going to be rolling, and if we want to modify the result of those dice before we send the result back, we'll pass that in as an integer. So we set up the class, but we haven't actually written any code in it yet. Right now, if we try to call roll, it's going to throw an exception at us, and that's okay, because it's not quite time to start implementing this. Because if we follow our scientific method, first we have to list out our assumptions. First assumption is that our DiceBag exists and is ready to use. After that, we have to make sure that the result of rolling a die is always a positive number. And we should say, yeah, roll 1 math rock, expect positive. Okay. And we just want to make sure that the result of that die roll is greater than 1. And Mrs. is getting ready to go out the door. She's going tubing today with some friends, and I am being a boring nerd, but that's okay. So we've got a couple other assumptions that we want to write some tests so that we can verify that those assumptions are safe to make. Another way that I've stated this is we write tests so that we can prove the things that we want to take for granted can safely be taken for granted. So the result of the unmodified roll is at least the number of dice we rolled. So we want to fact. That's a signal to the test runner that this method is something that we should run as a test. Public void DiceBag underscore roll n dice. Roll must be at least n. Pop up here. We're going to use the same arrange, act, and assert. And as a matter of fact, these first few lines all look the same. They're all actually going to be almost exactly the same. So let's paste these up down here. And we want our number of dice, let's say, is 6. We want to assert that, oh, and here's our friends. Our result is at least is greater than or equal to number of dice. And this test isn't going to work yet either, because of course we haven't written the code to actually make it do anything. All right. The result of the unmodified roll is not more than the number of dice times the number of faces they have. Let's set this up. Fact. Okay, have fun. Don't drown.
Nope.
Okie dokie. See you later. Roll and dice. Roll must be no more than num x sides. I really wish it had put my curly braces on their own line. Oop, here we go. And again, we are almost identical here. As far as a range and act, we might modify this. We can leave all of these things alone. And then down here under assert, dot is true. Assert is true. Result is less than or equal to now we could do this times int mathrock can't use is true because xunit doesn't have that method. It's just assert.true. So result is less than or equal to number of dice times int mathrock. That doesn't really read well. So int expected equals number of dice times mathrock. Oh, I did that wrong. Mistyped it. So mathrock is an enum, so we can't just multiply by that value. So even though mathrock kind.d2 equals 2, we should still cast that as an integer. Although we might be able to get away with not. Oh no, we can't. Because you can't multiply an integer times an enum. So let's put that cast back in. And instead of having our formula to calculate our expected result, we need to do expected. Excuse me. And then our final assumption that we want to test says we rolled the correct number of dice. Set up the method, public void DiceBag expect dice rolled equals num dice. So let's just copy all of this stuff. Actually, we can copy all of this stuff and set up our assert. Assert dot pardon me, equal, and we will say expected and result. And we've got these other operators down here. I bet instead of doing assert true, we can say, just for laughs, assert dot do we have, nope, is, nope, assert, oh, come on, dot, is there a greater than? There's equal, does not match, does not contain. Proper subset, raises any, single, blah, 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 throws any. Nope, I guess we have to just use .true. And we'll evaluate that expression into expected up there. Now, this could become kind of problematic, but we'll get there. We're going to learn about failing tests and how to handle them and all of that stuff as we go. So let's come over to our test runner and we'll run everything. We see that it updated to 5 tests. And excuse me for just a moment, I've got a bit of a tickle in my throat. Excuse me. All right. Only one of our tests worked, and I think it was the constructor test. Let's go there. Yeah, the constructor test is the only thing that actually worked for us. Everything else failed because our class threw this not implemented exception. So let's get rid of that. We'll get rid of this. We'll just hide those for now. And let's pop in here. And we're expecting an integer back, so let's return 1. Rerun our tests. So some of them are going to pass, some of them aren't. So this one, we expected a positive integer. And yeah, our test passed, but it's not actually an accurate test. It's just the bare minimum. And we wanted to roll n dice, and the roll must be no more than x sides. Well, how many did we pass in? We passed in 6 dice, and our result was 1. So yeah, it passed the test, but it's wrong. And then, of course, expect the dice rolled to be equal to the number of dice we asked it to roll. Well, we asked it to roll 6, and we didn't roll any. We just hard-coded a 1 to come back. So that's not fantastic. So what we're going to do is we are going to set up an array. And it's going to be an array of ints. Int array rolls equals a new int array that has the number of dice. And we're just going to say for int roll equals 0, because arrays always start at 0 unless we specify otherwise somehow. While roll is less than number of dice, working in C#, not JavaScript. Roll. Yeah. Roll. Rolls. Roll. Equals. And we have to generate a random number. So, I believe for that we need var mathrock equals new math dot random. Is that how we do that? That would give us a constructor. That may not work. I never remember. Mathrock dot next. Now let's just close that and see what we got. Math.random. I don't think random does what we want it to. I'm going to have to go look up how to get a random number. In C# and dotNet 8, how do we generate random integers within a known range? And you'll forgive me, I don't carry this stuff around in my head. All right. So it says random equals new random. Int random number equals random.next 1 to 101. Inclusive. So it says here, now this is from an AI. We may or may not have to add that 1. Although down here it says we go next dot double times max number minus min number plus min number. Okay. That's some goofy stuff, but that's... all right. I actually don't trust this information. Stack Overflow. Let's go to Stack Overflow on this. I gotta verify. Yes, just eat the cookies. In range, okay, yeah, great. And it's just specifying that. And let's look at the random class over at MSDN. Let's go right to the source. So rand equals new random. Bytes, yeah. I don't care about random bytes. 5 random integers. Okay, between 0 and 100. Rand next 101. So they are adding 1 to the upper bound. All right. And math.random, mathrock next. And we need 1 and int dice kind plus 1. And you know what? I don't really need to use an array here. So I'm going to comment this out. Comment that out. I do need result equals 0. Result plus equals mathrock dot next. Lowest value is going to be 1. The highest value is, we have to cast as an int dice kind plus 1. And we'll return our result. Save that, try running our tests again. We're going to get a couple more pass. Yep, we sure did. And math.random didn't work. Random doesn't exist in the type math. Random does not exist. What are you even doing? Let's try running again, even though we've got that compiler error. Normally, Visual Studio will like recompile as I type and warn me about new things. Here we go. We've got a few new passing tests. So we know that our result is greater than 0. Fine. That's fairly easy to determine. Our unmodified roll is at least the number of dice that we rolled. Okay. Well, it ran it once, and we probably got a result better than 6. Our result must be no more than 6 times 2. So we can't get anything more than 6 times 2. So it probably did a number between 2 and 12, and that's okay. But we don't have any information here because we expected DiceBag expect dice roll equals num dice. Well, first off, we've got the wrong expected expression here. We got to get rid of that. And then, so we just fixed that first obvious problem with our test. And it's running. And our assert equal failed because the values are different. We expected to get 6 and we got 10 back. Well, let's see what's going on. So we passed in the number of dice, and we want to know that the number of dice that were rolled is equal to the number of dice that we asked for. So we pass in, we're asking for 6 dice to be rolled. Expected is 6. Result is the sum of all the dice we rolled. So there's no way to tell how many dice we rolled. It's actually kind of a good thing that I didn't delete that array code. because instead of just accumulating into our result, we can actually assign those to that, and we can say int result equals rolls dot sum. Let's use some link. All right. Let's try it again. And it is still failing. We expected 6, we got 10. We got 10 again. Don't really love that. Are we getting 10 every time? I'm getting texts from kids. All right. So I think we've got a fundamental problem in our interface here, because we want to make sure we are rolling the correct number of dice every time we call this thing. And we have no way of knowing that based on just returning the result. So perhaps an integer is not what we want our DiceBag to return. Maybe we need something else. We need something that A, gives us the number of dice, like actually shows us how many dice we rolled, what the roll on each die was, as well as the total. So we need some kind of object for that, or a class or whatever. So let's add a new contract. And it's going to be a class. Let's call it a DiceTray. This is a metaphor for a... Now this is... DiceTray carries the result of the roll operation back to whoever uses it. Whichever component uses it. Now, our DiceTray has a number of properties. First off, it's going to have private list of math rocks. Not math rock kind, but math rocks. Oh, for crying out loud, stop it. Math rock rocks. Now we don't have a math rock class either. we should define that. So let's add a new file. It's going to be a class, and it's going to be called a math rock. Boop. Now our math rocks have a property of math rock kind, and let's just call it kind. Public int num sides and we can make that read only because we can derive that from the math rock kind. So to do that, rather than set up a public property and blah, 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 we're just going to use an inline lambda for this. And we're going to say return int kind. And I don't think we actually need the return. Nope. All right. Now, we want to carry the result. Public int and let's just say what's a good name for the face that's up? Let's call it face value. No, that's a crappy name. Value? Yeah. And it may not have an integer, it may not have a value yet. Now, we don't actually want these to be rollable. Get private set. And let's make this a private set as well. And let's add a constructor. We're going to take in a math rock kind. Just call it kind. And int value. And we'll assign kind equals kind. Value equals value. Save. Now this cannot be rolled, so let's call it, I'm going to rename this to rolled math rock. Yeah, okay. It's a little janky, but that's okay. Our naming doesn't have to be perfect. So we've got rolled math rock. And I should change the name of the file while I'm at it, because we want our file names to match our class names and vice versa. So DiceTray is going to have a list of rolled math rock. And this is a private property, which means nothing from the outside can see this thing. And let's just set up our constructor, DiceTray, rocks equals new list of rolled math rock. There we go. And we're going to need to have a way to add math rocks as we roll them to our dice tray. So we go add public void add roll. Rolled. And let's say it's math rock kind and int result. Because I don't necessarily want the consumers of this to have to instantiate a new math rock and then add it and all that stuff. We'll just do this. So var roll equals new rolled math rock passing kind and the value. No, not the value, the result. Oh, come on. Where is my cursor? Result. And let's just add that roll. And then we need a way to get what is on the tray. So let's say public, and let's just use an integer array, get rolls. We're not going to pass anything in. And var rolls equals rocks dot select r dot value dot to array return rolls. So now we have a dice tray. We can add rolls to it, and we can get the rolls from it, and we'll see all those. And I think I want to change, yeah, get rolls is fine. Although we probably don't necessarily want that to be a function. Let's turn that into a property. So we'll pull this up here, because I like to put my properties above my methods and just below my constructors. So public int array rolls is, we can come down here, grab that, paste it up here. Tidy that up a little bit. And let's go. We need a way to see the sum of it because I don't want the consumers of my DiceBag to have to do that math on their own. So, public int result, and we're just going to pipe that to rocks dot sum of the value of each rock in our each math rock in our DiceTray. All right, so we've got a bunch of stuff in here, and we should probably, I would say definitely, because we've got some calculations in here, add some tests to it. So let's add a new file to our test suite. And it is going to be, I guess we just add a brand new test class, huh? Yep, class. And let's call it DiceTray tests. And we only need a couple. Here we go, public class, DiceTray tests, using system. Do I have all the things I need? Okay. We're good. GameTools.DiceEngine.tests. Okay, good. Now, fact, public void, DiceTray tests, constructor works. Var test object equals new DiceTray. Assert dot not null test object. That's all we care about there. Public void DiceTray tests can add math rock. We got to turn that into a fact. There we go. Go to the start. Var test object equals new DiceTray. So there's a range. Act is test object dot add roll, and let's say we rolled a d6. And why do we have an access violation exception? We want the result. Let's say the result is a 4. And then int expected rock count equals 1. And now we can assert dot equal expected rock count test object dot rolls dot length. Because we're dealing with an array and there's no need to mess with link here. Excuse me. And I'm sure there's a more memory efficient way of dealing with that list up here in our dice tray than converting it to, well, good, we're not. There's a reason I used a list here instead of an array, because once you declare an array, we should really just consider it to be fixed length, and you can't dynamically add and remove things to arrays without writing a ton of extra code. So I'm using a built-in .NET object called a list, which inherits from my collection, which ultimately inherits from an array. But list is just, it's got a lot of syntactic sugar around it, and it makes it a whole lot easier to work with rather than redimensioning my array every time and having to do all kinds of crazy algorithms over those data structures. Because I don't want to mess with those. I want to do stuff. I want to write code that does stuff. And I want to get to doing stuff quick. So we've got test object is DiceTray, test object add role. All right. And now finally, fact, public, void. And I didn't add comments for the experiments that I want to try here, just because I'm pulling them out of my head as I go. DiceTray test underscore add two sixes, expect result 12. Now that feels like a silly test, but we want to make sure that we're getting that sum method invoked properly. So var test object equals new DiceTray test object dot add role, and let's add a d6 with 6 test object dot add role d6 with a 6 var expected result equals 12 assert dot equal expected result test object dot result. Boop. All right. I don't expect our dice engine tests to work yet because we haven't changed anything over there. But let's just rerun all the tests in the project. We should get a new DiceTray test set pop up here in a second. It's got to build first. And here's our DiceTray tests. None of those ran, probably because I didn't add something that I needed to when I added the new class. Let's figure it out. Public class, DiceBagTests, yeah. Oh, this is doing those silly things. Why didn't my DiceTray tests run? Can I? Okay, so now it'll run them. Visual Studio Code is weird, man. All right, a constructor works. We can add multiples. And when we add a bunch of dice, they sum up to the amount that we expect. So that was a heck of a detour, but not really, because the value of this is we came up here and we had created a test for our assumption that we'd be able to know how many dice we rolled after we invoke this engine, and we discovered that our design wasn't going to satisfy that assumption or that need. So we had to come up with a way to fix that. Now, to make this work, we're going to have to come into iDiceBag And instead of returning an integer, it's going to return a DiceTray. Save that. And now we've just broken our DiceBag implementation out here because it no longer properly implements iDiceBag. So let's try building this guy. And we're going to get we're going to see a sea of red in just a second. All right, iDiceBag does not implement interface member, blah, 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 blah. And when you do coding for a while, you'll start to see this a lot. So all we're going to do here is we're going to change int to DiceTray. And we'll save it. And let's see if that resolves this. It doesn't yet. Let's rebuild. Okay, so that error went away. But result is an integer. It's not a DiceTray. So we're going to need, instead of messing around with this array here, let's say DiceTray result equals new DiceTray. We can get rid of that int result equals roles.sum because that's not right. Why is result still reporting wrong? Because the inline compiler, code action failed, C#, go to output. What's going on is, I feel like there's an extension misbehaving itself, but let's rebuild again. Just to make certain. Gosh, I miss Visual Studio. I need to find a job again so I can get a Windows machine. Okay, so MathRock is new random. Let's change MathRock to roll result. All right. And we don't need to assign it to this. We can go int value. Let's just do that. Equals roll result dot next. Why is that complaining? Oh, it hasn't caught up yet. Save. So we've got our value. We know our MathRock kind, or our dice kind in this case. Yeah. Now let's get this a little better. MathRock kind. There, that reads a little better. And now we say result dot add roll, and we say MathRock kind and value. Okay, now we got to rebuild our engine because for some reason Visual Studio Code has stopped running Roslyn in the background to check my syntax and all that good stuff as we go. None of our tests are going to work anymore. At least none of the ones in the DiceBag tests. Because we're not returning an integer. In fact, we've got all kinds of errors over there that we haven't fixed. But, you know, that's okay. Error building your test projects. It couldn't even run them. So expected, it's an int. From int to date time. DiceTray to date time. Why is it trying to turn these things into date times. So we have to revisit all of our assumptions here. And it won't take that long. So, DiceBag, roll 1 math rock, expect a positive result. Now, result here is no longer just an integer. Result is this. So to make it a little bit easier to read, is we're going to rename that to DiceTray. Now, our DiceTray can't be 0, but rolls. Now, rolls is still an array. Length. All right. Now, yeah, rolls is an array. Length. I'm not in love with that. But let's not fall down that particular rabbit hole. Okay, our result, let's rename this just so that it's a little easier to think about. So that's our DiceTray. And our DiceTray can't be the number of result greater than the number of dice, but our result can. Let's space that out a little bit. And our result, let's change that again. Rename to DiceTray, just so that we know what we're dealing with. DiceTray dot result is less than or equal to the number of dice times the number of sides. And we want to make sure we roll the correct number of dice. Well, let's do this. And rename DiceTray. And assert dot equal. Our expected is 6, the number of dice there. And our DiceTray dot rolls dot length. Save that. Let's try running our tests again. And we have all of our tests are working. That's great. We can take all of those things for granted. So this morning, we finished writing the tests for our initial DiceBag class. Or at least we finished writing the first batch of tests. And we discovered that we had made a mistake in our design of the DiceBag's behavior and the design of the component itself, because just returning a single number isn't going to give the rest of the components in our townsfolk generator the information they need necessarily to be able to operate. Sometimes we need to know what the individual results of each of the dice were. Sometimes we want to make sure we rolled the right number of dice, things like that. So what we had to do is we had to change this interface to return an instance of a new class called a DiceTray that represents that thing that we put on the table and we chuck our dice into when we roll to hit something or we cast the fireball, and we need to know how much damage we did to the little tiny shop and everything in it. So we got to roll like 17 d6 and count them up and so on. So we had to create a DiceTray class to represent that real world object. And we added some helper methods. And this gives us our individual rolls. This gives us our result. And when we were writing our tests for the DiceBag, the way we count the elements in an array is by querying its length. And I'm not in love with that language on this API. So I think what I want to do is add something to our DiceTray that gives us that. And I'm going to put this up under here. And I'm going to say public int roll count. And all this is going to do is say rocks.count. And I'm going to come out to our DiceBagTests, and instead of saying DiceTray.rolls.length, I'm just going to use roll count. And I used .length a couple other places here. DiceTray.result. Oh, we're expecting a positive number. We don't want to use rolls.length here. That's silly. We need DiceTray.result. I hit the wrong thing. And this is why we review our code. Now, there is another thing up here. DiceBag exists. I want to add one more test. I know it's going to pass, but I want to add it now just so that we've got it later in case when we're doing more iteration on this. Now our DiceBag, we don't need the test on DiceBag. Sorry, my bad. I need it on DiceTray. DiceTray tests, constructor works. Okay, the unit testing and TDD purists, this is where they take me out back and dip me in boiling tar and feather me. Int num rolls at new equals 0. Int result at new equals 0. Because all the unit testing books and people say you should only ever do one assertion per test. And normally I would agree, but in some cases when we want to test that the constructor works, basically that our object or our instance is not null and it's in the correct state when it exits the constructor, I think it's okay to bend that rule. I think it's perfectly okay to bend that rule. So assert.equal num rolls at new test object dot num rolls what did I call that on the DiceTray? Roll count. Roll count. And instead of num rolls, I'm going to say roll count. And we got to change that to match. Roll count. Very good. Assert dot equal result at new test object dot result. Save. Let's run them. We'll make sure everything's good. Everything is good. I am going to implemented the first few tests tests and the code to make them pass for the Dice engine. This afternoon, we're going to refine these tests because they're not great. Our DiceTray tests are okay because we've got a decent amount of flexibility. We've proven that we can add a math rock to the tray. When we add the math rocks, or when we have multiple math rocks, we can get the values back out, that kind of thing. I trust our DiceTray at this point. Our DiceBag, yes, our tests are passing, but we are performing exactly one operation. And that operation invokes a random number generator. And everybody knows that random numbers in computers aren't really real. They're all calculated from some seed value based on something. But running these tests against what's essentially a non-deterministic operation, running them only once doesn't give us a high level of confidence that the method actually is going to work every time. So what I want to do is I want to see if I'm gonna have to do some research on X units, syntax, and so on between now and this afternoon. But I want to parameterize these test methods so that I can pass, so that instead of hard coding the number of dice and what kind, we can pass it in and then run 1,000 different rolls across, a number of test cases so that we can test each and every one of those scenarios and then make sure that we get the right result back. We might have to modify our testing structures here because yes, these things prove that our method works each time we call it, but it doesn't actually exercise the code very well. It doesn't really exercise and prove our assumptions. So we're going to pick that up in this afternoon's session. I'm going to go at 1, and we'll see you all at that time. Take care, everybody.